All right, there's a lot on the screen. So this is a CRI. Go ahead, pause your video, get some paper, write down your answers or some notes before we go over this. Okay. So the graph on the left, the two graphs on the left, okay, they're both population graphs of paramecia. And so you don't need to know what paramecia are, but they're just organisms, and you can see the graphs are similar on the left. And so when you get a graph that goes up, that means the population is growing. There's more, they're reproducing, and that's because there's resources there. Now, when they plateau like this, as both of them, both graphs, they have resources and they reproduce, and at some point, all populations are going to plateau. That's because the resources are limited. There aren't infinite number of uh, there isn't an infinite amount of space, food, and stuff like that. So when they reach this plateau, that point right there, and that point right there, that's known as the carrying capacity. And that's just used to describe, that term is used to describe how much can that space or that ecosystem or that environment can hold of that organism. Okay, so that's how you read the graphs on the left. Let's take a look at part A, what it's asking. Identify the type of interaction on the graph on the right. So when you have a line that goes up, and let me just do this in one color. When you have a graph where one line goes up and the other one line goes down, that is called competition. So students sometimes say this is a predator prey, like the let's just call the graph that's red paramecium, and then the blue, let's call that blue paramecium, right? And so students will think the red paramecium are preying or eating the blue paramecium, and that's not the case, because if that was the case, then the red paramecium would run out of food and you would expect their graph to go down too. So if this is not already in your notes, you should add a graph of predator prey. So predator prey graph has two lines that are shifted a little bit, but they both go up and down. So predators and preys coexist, and they kind of depend on each other, or at least the predator depends on the prey, and those populations will zigzag. So that is what's called predation. All right. Anyway, back to the question. Kind of getting off task here. Just wanted to that's a very, very common thing that students say. All right. So this here is competition. Part B. Why do the graphs of the populations change when the two paramecium are together? So notice the graphs separated versus the graphs when those paramecium are put in the same place are different. And why do you think? Why do you think one survives and reproduces better than the other? All right, well they're after this, they're competing after the same resources. So one is better fit to access those resources. So you can say, let's just say the red paramecium, all right, red paramecium are better fit, or have better traits, which is what better fit means, has better fitness, or or traits to access, to better access resources. Okay, so if the paramecium are after some kind of food, the red ones are better able to access it, and then the blue ones won't, so they'll die out, and the red ones will populate more. Okay, part C. What change in the so what ecological change would allow both populations to exist beyond 16 days? Notice that 16 days, the blue paramecium are done. They're no more. Okay, they don't survive. Now, how could they survive longer? Well, it's not really easy to train. You're not. They're not going to evolve. In a few days. Um, so they're not going to develop better traits. And the question's asking specifically ecological changes. So things that happen in the environment. So more resources can be added. So if there was more food, or if there was more space, if that was preventing them from populating more, then those things could um, allow the blue paramecium to live longer, maybe just a few days, but probably not much longer. So the answer to part C is more resources available. Right, but probably wouldn't make much of a difference in the longer term because clearly the red paramecium are better adapted to this environment. But if there was more, then they would coexist a little more beyond 16 days. So I'm running on a small screen. I type this up for you if you want to pause the screen and check out the answer key.